Did you know that space is a place where the impossible becomes ordinary, where the laws of physics twist into knots, and reality itself seems to play by its own rules? Out there, beyond our blue sky, lies a universe brimming with mysteries that defy logic, where stars sing, planets rain diamonds, and black holes swallow light whole. And today, we're diving headfirst into that cosmic wonderland with 30 of the weirdest, most mind-bending facts about space exploration. These aren't just tidbits you'd find in a textbook. These are the stories that make even the most seasoned astronomers pause and say, "Wait, what? Think about this for a second. Every time we launch a probe, point a telescope, or send humans beyond our atmosphere, we're not just exploring space, we're unraveling a puzzle that's been billions of years in the making." And sometimes the answers we find are stranger than anything science fiction could dream up. Picture a moon where the volcanoes spew ice instead of lava, or a galaxy made almost entirely of dark matter, invisible to our eyes but bending the fabric of the universe around it. These aren't hypotheticals, they're real discoveries waiting to blow your mind. So buckle up, because this journey is going to be anything but predictable. We'll uncover secrets about astronauts' bizarre experiences in zero gravity, stumble upon celestial objects that shouldn't exist, and maybe even question everything we thought we knew about the cosmos. Whether you're a space enthusiast or just someone who loves a good "did you know" moment, there's something here to spark your curiosity. By the time we're done, you'll see the night sky and the universe beyond it in a whole new light. Ready to explore the unbelievable? Let's go. Here's something that might make you look at astronauts a little differently. They come back from space slightly taller than when they left. That's right, spending time in microgravity can stretch an astronaut's spine by up to 2 inches. Without Earth's gravity compressing their vertebrae, the space between each bone expands, essentially giving them a temporary height boost. Imagine floating weightless, your body no longer fighting that constant downward pull, and suddenly you're looking at the world, literally, from a new perspective. But this cosmic growth spurt isn't all good news. When astronauts return home, their bodies have to readjust to gravity's relentless squeeze, and that can be painfully awkward. Their spines, now elongated, slowly compress back to normal, often causing intense back pain as the vertebrae realign. And it's not just the bone's spinal fluids, which had redistributed upward in microgravity, suddenly rush back down, sometimes leaving astronauts feeling like they're carrying extra weight in their heads for days. Some even report temporary vision changes because of the fluid shifts. Think about that for a second. Space doesn't just change how you move or float, it reshapes you from the inside out. And while growing taller might sound like a fun perk, it's a reminder of just how much our bodies rely on Earth's gravity to function normally. Astronauts train for years to handle the physical toll of space travel, but some effects, like this strange stretching, are impossible to fully prepare for. It makes you wonder, if humans ever live long-term in space, how might our bodies adapt over decades? Would we eventually evolve to thrive without gravity's constant pull? For now, though, astronauts enjoy their extra inches while they can, before Earth brings them back down to size. Now imagine stepping onto another world, taking your first breath of moon dust, only to discover it smells like spent gunpowder. That's exactly what Apollo astronauts reported after their lunar walks, describing the clingy gray powder as having a sharp, metallic scent, almost like the aftermath of a fireworks display. But here's the twist: the moon has no atmosphere, no oxygen, no combustion. So why does it smell like something burned? The answer lies in the dust itself. Lunar regolith, that's the fancy term for moon dirt, isn't just ordinary soil. It's a jagged, glass-like powder forged by billions of years of meteorite impacts, shredding the moon's surface into tiny, razor-sharp fragments. But the real kicker, solar wind, a constant stream of charged particles from the sun, bombards these particles, embedding them with strange chemical quirks. When astronauts brought the dust inside their lander, mixing it with humid cabin air for the first time, those trapped solar particles reacted, releasing that eerie gunpowder tang. And this dust didn't just smell weird, it behaved weird. Unlike Earth's weathered sand, lunar dust is electrostatically charged, making it cling to everything like cosmic glitter. It gummed up suit joints, scratched helmet visors, and even snuck into the lunar module, leaving astronauts coughing as they inhaled the fine particles. Some crew members reported the smell lingered in their noses for hours, a haunting reminder of their alien adventure. Scientists think this bizarre phenomenon could be a preview of challenges future moon colonists might face. If we ever build bases there, this abrasive, chemically reactive dust could wreak havoc on equipment and human lungs. It's a reminder that space isn't just visually strange, it engages all our senses, sometimes in ways we'd never expect. So next time you catch a whiff of fireworks, remember, somewhere out there an entire world smells just like that. Here's something Hollywood never gets right: space is utterly, eerily silent. No roaring engines, no thunderous explosions, not even the faintest whisper of wind. In the vacuum between stars and planets, where there's no air to carry vibrations, sound simply doesn't exist. Think about the Apollo 11 moon landing. Those iconic grainy images of Neil Armstrong descending the ladder, not a single footstep echoed. The lunar module's engines fired in complete silence as it touched down, no matter how dramatic the moment looked on camera. This quiet is so absolute it messes with our earth-bound expectations. We're wired to associate movement with noise. A spaceship banking sharply should whoosh, a laser blast should sizzle, right? But in reality, if you were floating beside a supernova, you wouldn't hear a thing, even as the shockwaves ripped apart planets. That's why astronauts rely so heavily on radio comms. Without them, they'd experience the universe as a vast, soundless theater. The disconnect between reality and movie magic isn't just amusing. It reveals how deeply we anthropomorphize space. We project our own sensory world onto the cosmos, filling the silence with dramatic scores and explosive sound effects because emptiness feels unnatural to us. But the truth is far more unsettling. Out there, the most cataclysmic events unfold in perfect quiet. A collapsing star doesn't scream. A colliding pair of black holes doesn't boom. The universe's grandest spectacles play out like a silent film, visible but utterly voiceless. So why does this matter? Because silence shapes how we explore. Spacecraft designers prioritize vibration sensors over microphones. Astronauts train to interpret visual cues alone when outside their craft. And every time we send a probe into the void, we're reminded that the cosmos operates on terms wildly different from our own. Next time you watch a sci-fi epic with wall-to-wall sound, remember, the real universe is infinitely stranger and its quiet is louder than any explosion. Venus is the solar system's ultimate rebel. It spins backward, while nearly every planet, including Earth, rotates counterclockwise when viewed from above the North Pole. Venus defiantly spins in the opposite direction, a phenomenon called retrograde rotation. Picture this: if you could stand on Venus's scorching surface, the sun would rise in the west and set in the east, moving across the sky in reverse compared to what we're used to. But that's just the beginning of Venus's oddities. Scientists have two leading theories for why Venus flouts the norm. The first suggests a cataclysmic collision billions of years ago when a massive object, perhaps the size of a small planet, slammed into Venus with enough force to flip its rotation entirely. Imagine a cosmic billiard ball striking Venus sideways, sending it spinning backward like a top knocked off balance. The second theory points to tidal forces from the Sun's gravity and Venus's thick, sluggish atmosphere, which may have gradually braked and reversed its spin over eons. It's like trying to turn a jar of honey. The sticky atmosphere resists motion until forces eventually drag it the other way. And here's the real kicker: Venus's day is longer than its year. One full rotation, a single Venusian day, takes 243 Earth days, but it only takes 225 Earth days for Venus to complete an orbit around the Sun. That means if you lived there, your birthday would come before your next sunrise. Add in the planet's crushing atmospheric pressure and runaway greenhouse effect, and Venus isn't just backward, it's a blistering, high-pressure enigma, challenging everything we assume about how planets should behave. This bizarre behavior makes Venus a cautionary tale for planetary evolution. Earth and Venus are nearly twins in size and composition, yet their fates diverged wildly. One became a lush oasis, the other a toxic inferno spinning the wrong way. It's a reminder that the universe doesn't play by our expectations. Sometimes it flips the script entirely. Saturn isn't just famous for its rings, it's hiding one of the most mind-bending weather phenomena in the solar system. At its north pole, a colossal hexagon-shaped storm swirls with edges so precise they look like they were drawn with a cosmic protractor. This isn't some fleeting cloud formation. It's a 20,000-mile-wide monster big enough to swallow 4 Earths side by side. And the strangest part: it's been there for decades, stubbornly maintaining its 6-sided symmetry while Earth's hurricanes dissolve in a matter of days. What makes this hexagon so eerily geometric? On Earth, storms are chaotic, spiral-shaped systems, their forms dictated by fluid dynamics and the Coriolis effect. But Saturn's hexagon defies those rules. Scientists suspect it's a towering jet stream, a high-speed river of gas locked in a battle between atmospheric layers rotating at different speeds. Imagine stirring a cup of coffee so fast that the liquid forms standing waves. Now scale that up to planetary proportions, with winds whipping at over 300 miles per hour, and you've got a recipe for this otherworldly polygon. The precision is almost unsettling. Each side of the hexagon spans nearly 8,000 miles, with corners so sharp they could pass for geometric art. Even more bizarre, the storm's center harbors a swirling vortex like the eye of a hurricane, but instead of dissipating, the entire structure rotates in sync with Saturn's magnetic field. Some researchers think deep-seated electrical currents or shock waves might be sculpting this anomaly, while others propose that the hexagon is a standing wave pattern, frozen in time by the planet's unique atmospheric soup. Here's the kicker: nothing like this exists anywhere else in the known universe. Earth's weather is messy and organic, but Saturn's North Pole is a testament to how alien the laws of physics can become under extreme conditions. It's a reminder that the universe doesn't just break rules, it writes entirely new ones, and as we study this 6-sided enigma, we're left wondering what other geometric wonders might be hiding in the atmospheres of distant worlds. The Sun isn't just a bright light in the sky, it's a cosmic furnace so vast you could cram 1.3 million Earths inside its core alone. Wrap your mind around that for a second. Every mountain, every ocean, every city on our planet, multiplied over 1 million times, would still vanish into the Sun's searing heart like a handful of sand tossed into the ocean. But this staggering scale isn't just for show. It's the engine room of our solar system, where the magic of nuclear fusion transforms raw hydrogen into the light and heat that sustains everything we know. Picture the core as a chaotic atomic dance floor, where temperatures soar to a blistering 15 million degrees Celsius. At these extremes, hydrogen atoms normally too shy to interact get crushed together with such force that they fuse into helium, releasing unimaginable energy in the process. Every second, the Sun converts 600 million tons of hydrogen into helium, shedding 4 million tons of mass as pure energy. That's the equivalent of detonating 96 billion 1-megaton nuclear bombs continuously. And yet, from our safe distance of 93 million miles, all we feel is a gentle warmth on our skin. Here's what's wild: this fusion process is so efficient, it's kept the sun shining steadily for 4.6 billion years, with enough fuel left to burn for another 5 billion. The light hitting your eyes right now, some of those photons began their journey from the core tens of thousands of years ago, inching through the sun's dense layers like commuters in a cosmic traffic jam. By the time they break free into space, 8 minutes is all it takes to reach Earth, completing a journey older than human civilization. But scale isn't the only mind bender, it's the delicate balance that defies logic. The sun's core is a tug-of-war between gravity's crushing pull and fusion's explosive push, teetering on a knife's edge. If fusion sputtered out, gravity would collapse the sun inward in seconds. If fusion ran wild, it would blow the sun apart. Instead, it hums along in perfect equilibrium, a self-regulating powerhouse that's kept the planets in its orbit for eons. And here's the kicker: every atom in your body, the iron in your blood, the calcium in your bones was forged in a star like this, then scattered across the cosmos by ancient supernova. The sun's core isn't just a distant curiosity, it's the cosmic factory that built you. So the next time you bask in sunlight, remember, you're feeling the echo of 1,000,000 Earths worth of fire, a nuclear alchemy that connects us all to the universe's grandest rhythms. If you think waiting for sunrise takes too long on Earth, try standing on Mercury, where a single day lasts 59 Earth days. That's right, from one sunrise to the next, you'd spend nearly 2 months in darkness before the sun crawled back into view. But Mercury's timekeeping isn't just sluggish, it's downright surreal, thanks to a cosmic tug-of-war between its snail-paced rotation and its breakneck orbit around the sun. Here's the twist: Mercury's year-one full trip around the sun takes just 88 Earth days. That means its day is 2/3 as long as its entire year, a ratio unmatched by any other planet. Picture this: if you lived near Mercury's equator, you'd witness the sun rise agonizingly slowly, pause mid-sky, then reverse course and dip back below the horizon before rising again, all in the same day. This bizarre double sunrise happens because Mercury's orbit is so elliptical that its speed varies dramatically. At its closest approach to the sun, the planet's orbital velocity outpaces its rotation, making the sun appear to backtrack in the sky. It's like watching a car speed past you on a curve, only for it to suddenly slam into reverse. And while you're waiting for that second sunrise, brace yourself for temperature swings that make Earth's weather look tame. With virtually no atmosphere to trap or distribute heat, Mercury's surface bakes at 800 degrees Fahrenheit under the sun's glare, hot enough to melt lead, then plummets to negative 290 degrees in the shadows. That's a 1,000-degree roller coaster between day and night, all because the planet rotates so slowly that each side gets roasted or frozen for weeks on end. But Mercury's weirdness doesn't stop there. Its gravity is so weak that if you dropped a rock from shoulder height, it would take 6 seconds to hit the ground. And its surface, pockmarked with ancient craters, hasn't eroded in billions of years, making it a fossilized record of the solar system's violent youth. This tiny world, barely larger than Earth's moon, defies every expectation, proving that in space, even time and temperature play by different rules. Jupiter's great red spot isn't just a storm, it's a cosmic titan, a hurricane so vast it could swallow Earth whole with room to spare. For 400 years, this swirling maelstrom of crimson clouds has dominated Jupiter's atmosphere, a constant beacon in the gas giant's chaotic skies. But here's the unsettling truth: the storm we once thought immortal is slowly fading. Once wide enough to fit 3 Earths side by side, it's now barely larger than one, shrinking faster than anyone predicted. So what's strangling this ancient tempest, and could it one day vanish entirely? The story begins in the 1600s when astronomers like Giovanni Cassini first glimpsed a permanent spot on Jupiter through primitive telescopes. For centuries, observers tracked its shift, sometimes darkening, sometimes lightening, but always there. By the late 1800s, it earned its iconic name, its crimson hue likely caused by sunlight breaking apart chemicals like ammonia and acetylene in Jupiter's upper atmosphere. But the real mystery isn't its color, it's the storm's endurance. Earth's hurricanes fizzle out in days when they hit land or cool waters. Jupiter has no land, no oceans, just an endless buffet of hot, swirling gas. So why is this storm, which has outlasted empires, suddenly withering? Scientists point to two possibilities. First, Jupiter's jet streams rivers of wind roaring at 300 miles per hour might be stealing the storm's energy, like a treadmill gradually slowing a runner. The spot sits between two of these jets, and as they shift, they could be shearing off its edges, reducing it bite by bite. Second, smaller storms, those swirling white ovals peppering Jupiter's clouds, might be sapping its strength. Imagine a heavyweight boxer surrounded by lightweight fighters, each landing tiny blows that add up over time. But here's the twist: the great red spot isn't just shrinking, it's changing shape. Once an oval, it's now more circular, as if the storm is condensing into a tighter, more concentrated version of itself. Some researchers speculate this could mean it's stabilizing, trading size for longevity. Others warn it's a death spiral, with the storm eventually fraying into nothing. If current trends hold, it could vanish within our lifetimes or morph into something entirely new. What's at stake isn't just a celestial curiosity. The spot is a window into Jupiter's hidden depths, a way to study weather patterns on a scale unimaginable on Earth. Its demise could rewrite our understanding of how gas giants evolve, how storms live and die in alien atmospheres, and if it does disappear, Jupiter's face will change forever, losing the feature that's defined it for centuries. The universe doesn't do permanence, not even for storms older than telescopes. The great red spot's slow fade is a humbling reminder. Even the mightiest things in the cosmos are fleeting. Neutron stars are the universe's ultimate cosmic speed demons, spinning so fast they could complete 600 full rotations in the time it takes you to blink. Picture a city-sized object heavier than our sun, whirling at a fraction of the speed of light, its surface racing so violently that a single misstep would fling you into space. These collapsed stellar cores aren't just fast, they're impossibly dense, packing more matter into a single sugar cube than all the cars on Earth combined. If you could scoop up a teaspoon of neutron star material, it would weigh 1 billion tons, a crushing reminder of how extreme physics can get when gravity wins. This insane density is a relic of stellar death. When a massive star explodes in a supernova, its core collapses inward, squeezing protons and electrons together until they merge into neutrons. The result, a spinning orb so compact that it defies intuition. Drop a pebble onto its surface and it would hit with the energy of a nuclear bomb, the impact amplified by gravity 100 billion times stronger than Earth. Yet despite their ferocity, neutron stars have an eerie precision. Some, called pulsars, emit beams of radio waves with such regular timing that they rival atomic clocks. These beams sweep across space like lighthouse rays, and when they point toward Earth, we detect them as rapid, rhythmic pulses, cosmic metronomes ticking with unerring accuracy. But how do they spin that fast? Imagine an ice skater pulling in their arms to spin faster, except replace the skater with a dying star. As the core collapses, it conserves the original star's angular momentum, but now concentrated into a sphere just 12 miles wide. The result is a dizzying pirouette, accelerated to hundreds of rotations per second. Some pulsars even partner with companion stars, stealing material that whips them into even greater speeds, their beams slicing through the cosmos like celestial buzzsaws. Here's the kicker: these spinning tombs of dead stars aren't just curiosities, they're laboratories for the universe's most extreme physics. Their gravity bends light into rings. Their magnetic fields could strip data from every credit card on Earth from 1,000 light-years away, and their very existence probes the limits of matter itself, showing us what happens when atoms are pressed beyond their breaking point. Next time you glance at the night sky, remember, somewhere out there, a tiny, city-sized remnant of a star is spinning faster than a kitchen blender, singing its radio song into the void. Water is Earth's lifeblood, but it turns out our planet isn't the only place where this cosmic ingredient flows freely. Floating between the stars in Orion's nebula, vast clouds of water vapor drift through space containing enough H2O to fill Earth's oceans 24 trillion times over. That's not a typo, trillions of oceans worth of water, suspended in a single stellar nursery over 1,300 light-years away, and that's just the beginning. Closer to home, Mars hides enough ice beneath its rusty surface to drown entire continents if melted. The planet's polar caps alone hold enough frozen water to blanket its surface in a 35-foot deep global ocean. Then there's Europa, Jupiter's icy moon, where scientists believe a saltwater ocean twice the volume of Earth sloshes beneath miles of frozen crust. Geysers taller than Mount Everest spew this water into space through cracks in the ice, offering tantalizing clues about what might lurk below. But why does this matter? Because water isn't just a chemical compound, it's the universe's ultimate building block for life as we know it. Every living cell on Earth relies on water's unique properties to function. Its ability to dissolve nutrients, regulate temperature, and even shield DNA from radiation makes it irreplaceable. So finding it elsewhere, that's like discovering a pantry stocked with all the ingredients for life, just waiting for the right conditions to start baking. Here's where it gets wild. The water in Orion's nebula didn't form the way Earth's did. Instead of condensing on a rocky planet, it was forged in the frigid vacuum of space, where oxygen atoms from dying stars bonded with hydrogen left over from the Big Bang. This means water isn't some rare cosmic accident, it's a natural byproduct of stellar chemistry, sprinkled across the galaxy like celestial confetti and Europa's hidden ocean. It doesn't just have water, it likely has hydrothermal vents, much like those in Earth's deepest oceans where life thrives without sunlight. If microorganisms can flourish around superheated cracks on our seafloor, why not under Europa's ice? The implications are staggering. We may not need to find another Earth to find life. A dark, briny ocean around a distant moon could harbor swimming microbes, floating jellyfish-like creatures, or even organisms we've never imagined. Mars offers a different story. Its water isn't liquid today, but billions of years ago, rivers carved canyons deeper than the Grand Canyon, and lakes splashed where dust storms now rage. If life did arise there, its remnants might be frozen in the ice, waiting for a rover or future astronaut to uncover them. Each of these discoveries rewrites the rules of biology, proving that water, and perhaps life, isn't bound to our pale blue dot. The universe seems to be whispering a secret. Water is everywhere. From nebulas to icy moons, it's a cosmic constant, hinting that life's ingredients are as common as starlight. The question isn't whether we'll find extraterrestrial water worlds, it's what's already living in them. Space isn't just full of stars and planets, it's cluttered with our leftovers. Right now, over 23,000 human-made objects larger than a softball zip around Earth at bullet-like speeds, from defunct satellites to a toolbox accidentally dropped by an astronaut. But the real oddities, a single glove lost during a spacewalk in 1965, a toothbrush that floated away during a repair mission, even a spatula that escaped during a shuttle launch. These aren't just curiosities, they're ticking time bombs in a high-speed game of cosmic pinball. Every piece of this debris orbits at roughly 17,500 miles per hour, fast enough to turn a stray bolt into a wrecking ball. In 1996, a French satellite was obliterated by shrapnel from a rocket that had exploded a decade earlier. In 2009, an intact communications satellite collided with a defunct Russian one, creating 2,000 new fragments in an instant. And this isn't just a remote risk. The International Space Station regularly dodges debris, its armored hull peppered with tiny dents from paint flecks striking like bullets. The nightmare scenario, Kessler syndrome, a chain reaction where one collision spawns more debris, triggering more collisions until low Earth orbit becomes an impassable minefield. Imagine a car crash where every shattered piece causes another crash, eventually gridlocking the highway. In orbit, that would mean no safe path for launches, no functioning satellites cutting off GPS, weather forecasting, and even some communications. Some estimates suggest we're already past the tipping point. Even if we stopped launching today, debris would keep multiplying. But here's where it gets surreal. Solving this might require sci-fi ingenuity. Proposed fixes include giant nets, harpoons, and even lasers to nudge debris toward the atmosphere where it would burn up. The European Space Agency plans to launch the first active cleanup mission, targeting a single derelict satellite like a cosmic garbage collector. Meanwhile, companies are designing satellites to fold into graveyard orbits or burn up intentionally at mission's end. The irony, space junk is the one frontier where not exploring might be our only salvation. Every bolt, glove, and toothbrush we leave behind could slam the door on future exploration, trapping us on Earth with a shell of shrapnel. It's a stark reminder, humanity's greatest legacy in space might not be footprints on the moon, but a floating junkyard we can't escape. Mars flips one of Earth's most familiar sights upside down literally. While our sunsets paint the sky in fiery reds and oranges, the Martian horizon fades into a serene, cool blue. This striking difference isn't just about aesthetics, it's a physics lesson written in dust and light, revealing how alien atmospheres can warp even the simplest experiences. On Earth, sunlight has to plow through thick layers of atmosphere at sunset, scattering shorter blue wavelengths and leaving longer red ones to dominate the sky. But Mars's whisper-thin air, just 1% as dense as ours, plays by different rules. Its fine dust particles, constantly suspended in the atmosphere, are just the right size to scatter blue light more efficiently, like trillions of tiny prisms. When the sun dips low, that scattered blue gets concentrated along the horizon, while the surrounding sky takes on a rusty hue from the planet's ever-present iron oxide dust. The result, a sunset that looks like it's been color graded for a sci-fi film, with a pale blue sun sinking into a pinkish sky. Here's the twist, this isn't just a quirk of light, it's a clue to Mars's volatile weather. Those dust particles don't just hang there, they're whipped into global storms that can engulf the entire planet for months. When NASA rovers captured the first high-resolution images of these blue sunsets, scientists realized the color intensifies after dust storms as fresh particles flood the atmosphere. It's a real-time barometer for Martian meteorology, written in shades of azure, and the sun itself, from Mars, it appears only 2/3 the size we're used to, a petite diamond set against that surreal blue glow. The effect is so hauntingly beautiful, it made some rover team members emotional when they first saw the images. Imagine standing on the rust-colored soil, watching this delicate blue disk vanish below the horizon, knowing the next sunrise won't come for 24.5 hours. It's a reminder that even the most mundane moments like a sunset become extraordinary when the rules change. This cosmic color swap isn't just a curiosity, it's a masterclass in how atmospheres sculpt worlds. Venus's thick clouds turn its sunsets into a dim, sulfuric haze. Titan's methane-rich skies might cast an eerie orange glow. Each planet's sunset is a fingerprint, revealing the secrets of its air, dust, and even its history. Mars's blue farewell offers more than a pretty picture. It's a postcard from an alien world, written in the only language light knows how to speak. The pillars of creation, those towering tendrils of cosmic gas immortalized by the Hubble telescope, might already be cosmic dust, and we're just the last to know. These iconic columns, stretching 5 light-years tall in the Eagle Nebula, aren't a snapshot of deep space as it exists today. They're a postcard from 7,000 years ago, delayed by the sluggish speed of light. And by the time those photons finally reached Hubble's lens in 1995, A shock wave from a nearby supernova could have already obliterated them, leaving us staring at a celestial ghost. Here's what makes this eerie. Everything we see in deep space is a time capsule. The farther away an object is, the older the light we're receiving. The Eagle Nebula sits 7,000 light-years from Earth, meaning every glittering star and wisp of gas in Hubble's famous image is a fossil from around the time humans were inventing the wheel. But in 2007, astronomers using infrared telescopes spotted something ominous, a heat signature suggesting a supernova shockwave had already swept through the region. The pillars, made of fragile dust and hydrogen, would have stood no chance against that blast. If the calculations are right, those majestic towers were reduced to interstellar debris millennia before the pyramids were built. Yet there's a haunting beauty to this cosmic lag. We're essentially watching the universe's greatest magic trick, the art of making something vanish while it still appears to exist. The pillar's slow-motion demise forces us to confront how disconnected our perception is from reality in space. Those images aren't just pictures, they're layers of time stacked like pages in a history book with the final chapter already written but unread. And the twist, even if the pillars are gone, their legacy isn't. Supernovas are demolition crews and construction workers. Their explosions seed space with heavy elements that birth new stars. The same shockwave that might have dismantled the pillars could have compressed nearby gas, sparking the next generation of stellar nurseries. It's a reminder that in space, destruction and creation are two sides of the same coin. The universe doesn't mourn lost structures, it recycles them. So when you gaze at Hubble's iconic photo, you're not just seeing a pretty space cloud. You're witnessing a moment frozen between life and death, a monument to time's cruel trickery. The pillars may be dust, but their lesson endures. The cosmos doesn't wait for us to catch up. Some of its most breathtaking spectacles are already memories by the time we see them, echoes of a past we'll never touch. Uranus doesn't just orbit the sun, it rolls around it like a cosmic barrel knocked sideways. While most planets spin like tops, Uranus tilts at a jaw-dropping 98 degrees, essentially rotating on its side with its poles where its equator should be. Picture this: if Earth had the same tilt, the Arctic Circle would stretch all the way to Texas, and the sun would loom directly overhead at the North Pole for half the year before vanishing into months of darkness. But Uranus's bizarre posture isn't just a celestial quirk. It's a clue to one of the solar system's most violent family secrets. Scientists have long suspected that this extreme tilt wasn't original. The leading theory, a cataclysmic collision with an Earth-sized object billions of years ago, a hit so brutal it sent Uranus reeling. Imagine a cosmic billiard ball smashing into the planet with enough force to flip its entire axis, leaving it spinning sideways like a wheel rolling downhill. Computer simulations show such an impact could have also stripped away lighter gases, explaining why Uranus, unlike its gas giant siblings, holds a surprising amount of icy material in its core. It's as if the universe delivered a sucker punch so hard, it reshaped the planet's very identity. The consequences of this tilt are as dramatic as they are bizarre. Each Uranian season lasts 21 Earth years, but here's the catch. During summer and winter, one pole faces the sun continuously while the other drowns in darkness. For nearly a quarter of a Uranian year, half the planet bakes under relentless sunlight, while the other half freezes in an endless night. Then, during spring and fall, the sun skims the equator, creating a fleeting period where day and night alternate until the next extreme takes over. But the weirdness doesn't stop there. Unlike other planets where magnetic fields align roughly with their rotation axes, Uranus's magnetic field is off-kilter by 59 degrees, and it doesn't even emerge from the planet's core. Instead, it bubbles up from a lopsided layer closer to the surface, as if the impact scrambled its internal dynamo like a blender. Even Voyager 2's flyby in 1986, the only close-up visit to date, left more questions than answers. The planet's weather systems move sluggishly, lacking the raging storms of Jupiter or Saturn, yet its upper atmosphere somehow manages to be the coldest place in the solar system, dipping to negative 370 degrees Fahrenheit colder than distant Pluto. This sideways world forces us to rethink how planets evolve. Was Uranus born this way, or did a single violent encounter rewrite its destiny? Could similar collisions have shaped other worlds we've yet to study? For now, Uranus spins on, a silent testament to the chaos of the early solar system, a reminder that even giants can be knocked sideways by the universe's unpredictable whims. And as we ponder its oddities, one thing's clear: normality is relative, and in space there's no such thing as upright. Imagine floating in zero gravity, overcome with emotion only to find your tears refuse to fall. In space, crying isn't the cathartic release it is on Earth. Without gravity to pull them downward, tears don't stream down cheeks. They cling to the eyes in quivering, ever-growing domes of salt water. Astronauts describe the sensation as strange, even uncomfortable, like wearing liquid goggles that blur vision but never drain away. Some say it feels like the sadness itself gets trapped, literally pooling on the surface of their eyes. This peculiar phenomenon isn't just a curiosity, it's a visceral reminder of how space rewrites bodily instincts. On Earth, tears lubricate our eyes, then trickle away, carrying emotional stress with them. But in orbit, they accumulate until they either coat the eyeball entirely or detach as floating spheres, tiny, shimmering globes of grief or joy drifting through the cabin. NASA astronaut Andrew Fustel once recounted how, during a moment of homesickness, his tears formed such a thick bubble that it stung like soap in his eyes until he wiped it away. Others, like Italian astronaut Luca Pomitano, realized mid-mission that their crying reflex didn't just feel alien, it was alien, a biological response rendered useless by physics. But here's what's even more revealing. Astronauts often report that space doesn't just change how they cry, it changes when. In the overwhelming silence between Earth and the stars, surrounded by endless blackness, emotions hit differently. Some describe unexpected surges of awe or loneliness so profound that the tears come unbidden, only to linger awkwardly. Sunita Williams shared how viewing the Himalayas from orbit moved her to tears, only for the experience to turn surreal as those tears hovered in her lashes like diamonds. Others, like Chris Hadfield, noted that the absence of familiar emotional outlets like a good Earth-style sob forced them to adapt, finding new ways to process stress through music, photography, or shared laughter. Yet this isn't just about discomfort. These floating tears symbolize a deeper truth. Space exploration isn't just a technical challenge, it's a profoundly human one. Every droplet suspended in microgravity is a reminder that our bodies, evolved over millennia for Earth's embrace, are strangers in the cosmos. And as we venture farther to Mars and beyond, these small, intimate struggles, like learning how to cry all over again, will shape the future of life among the stars. The next time you wipe away a tear, think of those orbiting Earth, their sadness and joy crystallized in fragile spheres, waiting for gravity's return to finally let them fall. You might think the coldest place in the universe is some distant void between galaxies, but the record holder is actually right here on Earth, in a lab no bigger than your kitchen. Scientists have created Bose-Einstein condensates, exotic states of matter chilled to within a billionth of a degree above absolute zero, the theoretical temperature where all atomic motion stops. That's colder than the depths of space, which hovers around a balmy 3 degrees above absolute zero thanks to the faint glow of the Big Bang. How do you out-chill the cosmos? The secret lies in trapping atoms with lasers and magnetic fields, then carefully siphoning away their heat like a cosmic refrigeration system. Imagine slowing a speeding bullet to a near standstill, except the bullet is a cloud of rubidium or sodium atoms. At these extreme temperatures, quantum effects take over. individual atoms lose their identities, merging into a single blob of matter called a superatom, where particles move in eerie unison. It's like an atomic ballet where every dancer moves in perfect sync, a phenomenon Einstein and Satyendra Bose predicted in the 1920s, but no one could observe until decades later. Here's the twist: while space itself is cold, it's not empty enough to reach these extreme lows. The universe's background radiation, the afterglow of the Big Bang, keeps even the darkest voids at a baseline of 3 Kelvin. But in Earth's labs, we can create conditions far more extreme than nature ever does. The coldest spot ever recorded was in a Massachusetts lab in 2015, where researchers hit negative 459.67 degrees Fahrenheit, just 150 quadrillionths of a degree above absolute zero. Why does this matter? Because studying matter at these temperatures reveals quantum behaviors that could revolutionize technology. Superconductors that work at room temperature, ultra-precise quantum sensors, even exotic new states of matter, all could emerge from understanding how atoms behave when pushed to the edge of motionlessness. And it's a reminder that sometimes the universe's most extreme frontiers aren't light years away there in a lab down the street, hiding in plain sight. So next time you shiver on a winter morning, remember, humanity has created pockets of cold so profound they make interstellar space feel like a tropical getaway. The cosmos may be vast, but it's no match for our curiosity or our ability to push the limits of physics right here at home. Pluto's journey around the Sun isn't just slow, it's a glacial marathon stretching 248 Earth years to complete a single lap. That means since Pluto was discovered in 1930, it hasn't even finished one full orbit. If you were born on Pluto, somehow surviving the negative 387 degree Fahrenheit winters, you'd celebrate your first birthday around the year 2278. But Pluto's orbit isn't just long, it's a cosmic roller coaster, looping wildly closer and farther from the Sun than any planet in our solar system. Picture this: when Pluto is at its closest approach, it actually dips inside Neptune's orbit, basking in a brief, slightly warmer phase before hurtling back into the frozen depths. This elliptical path isn't just a quirk. It's a symptom of Pluto's chaotic relationship with Neptune's gravity. The two worlds are locked in what's called a resonance. For every 3 laps Neptune takes around the Sun, Pluto completes exactly 2, a celestial dance that keeps them forever in sync but never colliding. It's like 2 runners on a track, one lapping the other at precise intervals without ever tripping over each other. And then there's the identity crisis. In 2006, Pluto got demoted from planet to dwarf planet, not because it shrank, but because astronomers realized it wasn't the heavyweight they'd thought. The discovery of Eris, another icy world beyond Pluto and slightly more massive, forced a cosmic reckoning. If Pluto kept its title, the solar system would soon be overrun with planets. So the International Astronomical Union drew a line. To be a planet, you must orbit the Sun, be round from gravity, and clear your neighborhood of debris. Pluto failed that last test miserably, sharing its icy realm with thousands of other Kuiper Belt objects. But here's the twist: Pluto's reclassification wasn't a demotion, it was a promotion to King of the Dwarfs. The New Horizons flyby in 2015 revealed a shockingly complex world. Ice mountains taller than the Rockies, glaciers of frozen nitrogen, even a heart-shaped basin named Tombaugh Regio that might hide a slushy underground ocean. Its thin atmosphere, hazy with methane, creates blue sunsets eerily similar to Earth's. And those 5 moons, the largest Charon, is so big relative to Pluto that they orbit a shared point in space, making them more of a double dwarf planet than a moon and planet pair. Pluto's marathon orbit and icy grandeur force us to rethink what makes a world worth exploring. It's not about titles, it's about the stories hidden in the frozen fringes. And as New Horizons' grainy images proved, even the smallest worlds can hold the biggest surprises. ever walked into a room and immediately noticed a strange, lingering odor? Space has its own version, except astronauts don't just smell it, they bring it back with them. After spacewalks, crews report an unmistakable scent clinging to their suits, described as everything from seared steak and hot metal to gunpowder and welding fumes. It's a smell so distinct, some compare it to the acrid tang of ozone after a thunderstorm, sharp, metallic, and oddly industrial. So where does this cosmic aroma come from? The culprit is atomic oxygen, a form of oxygen where atoms aren't paired up like we're used to in Earth's atmosphere. In space, high-energy solar radiation breaks apart normal oxygen molecules, leaving single atoms to run amok. When astronauts venture outside their spacecraft, these lone oxygen atoms latch onto their suits, tools, and even their gloves. Back inside, the atoms react with the humid cabin air, creating that peculiar burnt metal scent. It's like the entire universe took a blowtorch to a steel beam and left the fumes to linger. But here's the twist: this smell isn't just on the astronauts, it is them in a way. When atomic oxygen sticks to their suits, it's essentially oxidizing the outer layers, the same chemical process that causes iron to rust or apples to brown. That means every time an astronaut returns from a spacewalk, they're carrying traces of space's corrosive chemistry back with them, a scent that clings like the aftermath of a fireworks show. The descriptions vary slightly. Some say it's more like spent gunpowder, others swear it smells like a hot grill, but one thing's consistent: it's nothing like the sterile, odorless void we imagine. Even moonwalkers noticed it. Apollo crews reported lunar dust had a similar gunpowder-like smell, suggesting that chemical reactions in airless environments leave behind a signature stench, whether in orbit or on a rocky surface. This phenomenon isn't just a quirky footnote, it's a clue to how space alters materials and maybe even how future explorers will experience the cosmos. Imagine a Mars colony where every airlock cycle brings that same metallic tang inside, or interstellar travelers growing so familiar with the scent they associate it with home. Space doesn't just look alien, it smells alien too, a sensory reminder that we're visitors in a realm that follows its own rules. And every time an astronaut wrinkles their nose at that burnt steel whiff, they're inhaling proof that the universe engages all our senses, even the ones we never expected. The moon isn't just Earth's silent companion, it's a slow-moving fugitive, creeping away at the rate your fingernails grow. Every year, our lunar neighbor drifts 1.5 inches farther into space, a glacial escape fueled by the ocean's relentless tug of war with gravity. This might sound negligible, but over cosmic timescales, it adds up to something extraordinary, a future where moonlit nights vanish entirely, leaving Earth in permanent darkness. So why is the moon slipping away? Blame the tides. As Earth rotates, its oceans bulge toward the moon, creating a gravitational drag that acts like an orbital brake. But the moon doesn't just pull on Earth, Earth pulls back, stretching the moon's shape ever so slightly. This tidal friction transfers energy, nudging the moon into a higher orbit. It's like a cosmic game of catch where Earth keeps tossing the moon farther without realizing it's losing the game. Now imagine a world without moonlight. Nights would plunge into near total blackness, save for starlight. No more silver glow on waves, no eclipses, no cultural touchstones like harvest moons lighting autumn skies. Migratory animals tuned to lunar cycles would lose their celestial compass. Even Earth rotation would slow, lengthening days until a single rotation takes 47 of our current hours. Without the moon's stabilizing pull, Earth's axial tilt could wobble wildly, triggering climate chaos. Think ice ages and scorching droughts cycling unpredictably. But here's the twist: this escape isn't infinite. The moon won't vanish into the void. Eventually, Earth's rotation would slow to match the moon's orbit, locking the two in a gravitational embrace where one side of Earth always faces the moon. Tides would freeze in place and the retreat would stop, but not for billions of years. By then, the sun may have swollen into a red giant, rendering the whole debate moot. For now, the moon's slow departure is a reminder of how fragile our cosmic ballet really is. That gentle glow outside your window, it's a fleeting gift one future civilizations might only read about in history books. So the next time you gaze up at a full moon, savor it. You're witnessing a relationship that's quietly, inevitably unraveling. Black holes aren't the silent voids we imagine they sing. In 2003, astronomers using NASA Chandra X-ray Observatory discovered something astonishing. Sound waves rippling through the scorching gas around a supermassive black hole in the Perseus galaxy cluster. But this wasn't just random noise, it was a deep, resonant note humming at a frequency 57 octaves below middle C, a tone so low, it's a million billion times deeper than the limits of human hearing. To make it audible, scientists had to transpose it up by those unthinkable octaves, revealing a ghostly, almost meditative drone that defies everything we assume about the silence of space. This cosmic music isn't some abstract metaphor. Those sound waves are literal pressure ripples, vast, slow-motion compressions moving through the superheated plasma surrounding the black hole. Picture dropping a stone into a pond, except the pond is a cloud of gas millions of degrees hot, and the ripples take millions of years to complete a single cycle. The result is the deepest note ever detected in the universe, vibrating at a frequency roughly equivalent to a B-flat, but stretched so impossibly long that one beat would last 20 million years. Here's what's wild. This eerie hum isn't just a curiosity, it's a tool. The Perseus black hole's sound waves carry enough energy to heat the surrounding galaxy cluster, acting as a cosmic thermostat that prevents trillions of stars' worth of gas from cooling into new galaxies. It's like a supermassive black hole singing a lullaby to the cosmos, its voice shaping the very structure of the universe around it. And Perseus isn't alone. Other black holes likely sing too, their voices too deep for our ears but echoing across the void nonetheless. Now listen closer. That sound isn't just a scientific novelty, it's a relic from a time before Earth existed, a vibration older than continents, older than multicellular life. When those waves first began their journey, dinosaurs hadn't yet evolved, and the Atlantic Ocean was just a crack in the crust. By the time they reached Chandra's detectors, humanity had already mapped the genome and landed on the moon. The black hole's song is a time capsule, a reminder that the universe doesn't just look majestic, it sounds majestic in ways we're only beginning to hear. So the next time you gaze at the night sky, remember, it's not just a silent expanse. Somewhere out there, a black hole is humming a note so profound it sculpts galaxies, a cosmic bassline written in the language of gravity itself. And thanks to science, we can finally listen in. Somewhere in the constellation Cancer, about 40 light-years from Earth, there's a planet that would make even the most extravagant jeweler gasp. 55 Cancri isn't just another rocky world, it's a cosmic diamond the size of Neptune, glittering with a core potentially made of crystallized carbon. Scientists estimate this exotic gemstone of a planet could contain 10 to the 26th power carats of diamond. To put that incomprehensible number in perspective, it's more diamonds than every grain of sand on every beach on Earth combined. This isn't science fiction, it's the result of a stellar recipe gone wild. Most planets form from the same dusty soup as their parent star, rich in oxygen and silicon. But 55 Cancri orbits a carbon-heavy sun, meaning its building blocks were overloaded with carbon atoms. Under extreme heat and pressure deep in the planet's core, those carbon atoms could have compressed into a diamond lattice stretching thousands of miles. Imagine a world where mountains aren't made of rock, but of flawless planet-sized gemstones. But here's the catch, this diamond isn't sitting pretty in some cosmic display case. 55 Cancri is a hellscape. It's tidally locked to its star, meaning one side forever faces the scorching heat while the other freezes in eternal darkness. Surface temperatures on the sunlit side soar above 4,000 degrees Fahrenheit, hot enough to vaporize most metals. The atmosphere, if it exists at all, might be a poisonous mix of hydrogen and helium, with skies that rain molten silicates instead of water. Even the diamond core likely isn't the pristine gem we imagine. At those pressures, it could be more like a dense, conductive form of carbon resembling industrial diamond grit rather than jewelry. Why does this matter? Because 55 Cancri E shatters our assumptions about planetary diversity. It's proof that under the right conditions, planets can become almost anything: carbon kingdoms, molten gem factories, worlds where the very ground beneath your feet would be worth a fortune back on Earth. And it's not alone. Astronomers have spotted other carbon-rich worlds, suggesting the galaxy might be littered with diamond planets, each a monument to the universe's alchemy. Of course, mining this cosmic treasure is pure fantasy for now. The planet's extreme conditions would vaporize any probe within seconds, and even if we could reach it, the diamond core is buried under thousands of miles of superheated material. But its existence sparks bigger questions. How many other exotic worlds are out there? Could there be planets made of sapphire or rubies or substances we haven't even named yet? 55 Cancri E isn't just a curiosity. It's a glimpse into the infinite variety of the cosmos, where even the rarest things on Earth are just cosmic commonplaces. We think of the sun as a steady, reliable presence, but sometimes it throws a cosmic tantrum so violent it can knock civilization back to the Stone Age. In 1859, the most powerful solar storm in recorded history erupted from the sun's surface, hurling a torrent of charged particles toward Earth with the force of 10 billion atomic bombs. When they hit, the results were apocalyptic. Telegraph systems, the Victorian internet, went berserk. Sparks flew from equipment, shocking operators and setting papers ablaze. Some operators disconnected their batteries, only to find the aurora-induced currents were so strong the lines kept transmitting. The northern lights, normally confined to polar regions, blazed as far south as Cuba, painting the sky in blood-red curtains so bright people could read newspapers by them at midnight. This was the Carrington event, and if it happened today, our hyper-connected world would face catastrophic consequences. Fast forward to the 21st century, where our reliance on technology has turned solar storms from a curiosity into an existential threat. A Carrington-level flare today wouldn't just fry telegraph wires, it would cripple GPS satellites, knock out power grids across continents, and potentially collapse the internet itself. Imagine waking up to find your phone's navigation useless, flights grounded as air traffic control loses tracking, and banking systems frozen mid-transaction. Transformers, the massive nodes that distribute electricity, could overheat and melt under the surge, taking months or even years to replace. In 2012, a solar storm narrowly missed Earth. Scientists later calculated it would have caused $2 trillion in damage. The internet isn't immune either. Undersea fiber optic cables, the backbone of global communication, are vulnerable to geomagnetically induced currents. A severe storm could degrade their repeaters, creating digital blackouts that sever entire regions from the web. Unlike localized disasters, this wouldn't be a temporary glitch. It could take weeks to repair, collapsing supply chains, disrupting emergency services, and leaving billions in the dark. Some experts warn of an internet apocalypse where recovery isn't as simple as rebooting a server. Yet here's the unsettling paradox: for all our technological advancement, we're arguably more vulnerable than 19th century telegraph operators. Back then, the damage was spectacular but fleeting. Today, a single solar tantrum could trigger cascading failures with no quick fix. The sun doesn't care about our satellites, stock markets, or social media. It follows its own rhythm, and occasionally, it reminds us just how fragile our digital civilization really is. The irony, we see it coming. Modern observatories can detect flares hours before they strike, giving grids and satellites a slim window to power down. But without widespread preparation, those warnings might just be a countdown to chaos. So the next time your GPS glitches or the lights flicker, remember, the sun holds the ultimate veto over our tech-dependent lives. And one day, it might just decide to pull the plug. Time plays tricks in space, especially for astronauts orbiting Earth at 17,500 miles per hour. Thanks to Einstein's theory of relativity, every second spent aboard the International Space Station literally ticks slower than it would on the ground. Over a typical 6-month mission, astronauts return home approximately 0.005 seconds younger than if they'd stayed put. That might sound negligible, but it's proof that the universe bends time itself based on speed and gravity. Here's how it works. The faster you move, the more time slows down for you relative to someone standing still. This effect, called time dilation, means clocks on the ISS run slightly behind Earth-bound ones. Gravity also plays a role. Weaker gravity at orbital altitudes speeds up time, counteracting some of the speed-based slowdown. But velocity wins out, leaving astronauts with a net gain in youthfulness. It's like the universe handing them a microscopic coupon for extra time. Now, contrast this with Hollywood's portrayal in Interstellar, where hours on a high-gravity water planet equal years elsewhere. The movie's extreme time dilation isn't pure fiction. It's relativity pushed to its limits near a supermassive black hole. But while Interstellar dramatizes decades slipping away in moments, real-world astronauts experience a far subtler effect. Imagine if you could orbit Earth for 500 years, you'd still only shave off half a second compared to people below. The takeaway: time isn't the rigid constant we assume. It's fluid, stretching and compressing based on where you are and how fast you're moving. Every spacecraft that launches, every probe that races toward Mars, carries clocks that inch out of sync with Earth's, not due to malfunction, but because the universe itself recalibrates time like a cosmic accordion. And while astronauts won't return looking noticeably younger, their milliseconds of borrowed time whisper an incredible truth. The fabric of reality is far more flexible than our everyday lives suggest. So the next time you glance at a clock, remember, it's not just counting seconds, it's measuring your place in a universe where time is anything but absolute. Mars isn't just a frozen desert, it's alive with seismic whispers. NASA InSight lander, perched on the rust-colored plains of Elysium Planitia, has detected thousands of Mars quarks since its arrival in 2018, proving the red planet isn't the geologically dead world we once assumed. These tremors, some lasting over an hour, ripple through the crust like echoes of a distant, restless heartbeat. But here's the puzzle: unlike Earth's quakes, born from clashing tectonic plates, Mars's shudders seem to stem from something far stranger, a planet-wide cooling spasm, cracking its skin like a drying mudflat. The strongest Mars quark in sight recorded clocked in at magnitude 4.7, enough to rattle boulders but barely noticeable underfoot. Yet its duration was surreal, a slow, drawn-out vibration persisting for 94 minutes, far longer than any comparable quake on Earth. This lingering tremor hints at Mars's alien geology. Without active plate tectonics, the planet's crust behaves like a single, rigid shell. As the interior cools and contracts, stress builds until crack, the entire globe flinches, releasing energy in eerie, prolonged waves. But the real mystery lies deeper. InSight's seismometer revealed Mars's core isn't just molten, it's larger and less dense than expected, likely brimming with lighter elements like sulfur. This soupy core might still convect, stirring sluggish currents that occasionally flex the crust. Some scientists even speculate about pockets of magma lurking near volcanoes like Olympus Mons, which could trigger quakes if they shift or cool. It's a far cry from Earth's churning iron dynamo, but enough to remind us that Mars, for all its stillness, still simmers with hidden fire. What's fascinating is how these quakes paint a portrait of planetary aging. Earth, middle-aged and rowdy, slams continents together in seismic shouting matches. Mars, older and wearier, groans as it settles into its golden years, its wrinkles etched by slow contraction rather than tectonic drama. Each Marsquark is a fossil in motion, a clue to how rocky worlds evolve or fade over billions of years. And here's the kicker: this isn't just academic curiosity. Future Mars colonists will need to design quake-resistant habitats, especially if larger tremors lurk in the planet's history. InSight's data suggests Mars was far more volatile in its youth, with ancient faults capable of unleashing magnitude 7 quakes. Those forces may be dormant now, but the planet's seismic murmurs are a reminder. Even the quietest worlds have stories to tell if we know how to listen. Tucked aboard the Voyager probes, now hurtling through interstellar space, are two golden records humanity's calling cards to the cosmos. Launched in 1977, these 12-inch copper discs aren't just artifacts, they're time capsules, painstakingly curated to tell the story of Earth to any extraterrestrial civilizations that might stumble upon them. Etched with symbols explaining their origin and playback instructions, the records contain a dizzying mix of sounds, from the haunting songs of humpback whales to the crackling of thunder, the laughter of children, and even Chuck Berry's Johnny B. Good, it's a sonic snapshot of our world, a message in a bottle cast into the cosmic ocean. But here's the real puzzle: could aliens actually play them? The records were designed with universal clues: a pulsar map to locate Earth, diagrams of hydrogen atoms to explain binary code, even a stylus included in the casing. The idea was that any technologically advanced civilization would recognize the physics-based instructions. But what if their senses or tools are nothing like ours? Imagine a species that sees in radio waves or hears through pressure changes in liquid methane. The very concept of a spinning disk emitting vibrations might be as alien to them as their world is to us. The selection process itself was a fascinating act of optimism. Carl Sagan and his team agonized over what to include, knowing they had just 90 minutes of audio to represent all of human culture. They chose Mozart over Beethoven, greetings in 55 languages, and even the brainwaves of a woman in love. Yet some choices were controversial. Why Chuck Berry and not Beethoven's 9? The answer was deliberate. The team wanted to showcase not just high art, but the raw energy of human creativity. Berry's guitar riffs, they argued, captured something primal about our spirit. Critics argue the records are hopelessly anthropocentric, assuming aliens would understand our symbols, our music, even our concept of greetings. But supporters counter that it's the attempt that matters. The golden records aren't just about communication, they're a testament to our curiosity, our longing to reach beyond the void. Even if the discs never find an audience, they've already done their job. They remind us of what's worth preserving: the fragile, beautiful noise of life on Earth. And then there's the durability factor. These records are built to last 1 billion years in the harshness of space, their gold plating protecting them from cosmic rays. Long after human civilization is dust, long after the sun expands and scorches our planet, these golden discs will still drift, carrying the echoes of our existence into the infinite. So whether aliens ever spin them or not, the Voyager records are already a triumph, a whisper of humanity that refuses to fade into the dark. Deep in the large Magellanic Cloud, a satellite galaxy swirling around our own, there's a cosmic predator stalking the void, but this tarantula doesn't spin webs. The Tarantula Nebula, a sprawling stellar nursery stretching 160,000 light-years across, earns its name from the spindly filaments of gas that curl like a spider's legs around its glowing core. This isn't just another pretty cloud of space dust. It's one of the most violent and prolific star factories in the local universe, where newborn stars ignite so ferociously, their radiation carves cavities into the nebula's heart like scorch marks on silk. At the center of this cosmic web lies R136, a cluster of supermassive stars so bright They outshine our sun by millions of times. These aren't just stars, they're celestial blowtorches, pumping out enough ultraviolet light to ionize the surrounding gas into a kaleidoscope of pinks and blues. One of them, R13601, holds the title of the most massive star ever discovered, weighing in at a staggering 265 solar masses. To stand on a hypothetical planet near it would be like standing next to a nuclear explosion in permanent slow motion, your skin vaporizing before your eyes could even register the light. What makes the tarantula truly bizarre is its scale. If you plopped it into our Milky Way at the same distance as the Orion Nebula, Earth's closest stellar nursery, it would cast shadows on the ground at night, outshining every star in the sky except the sun. Its filaments, woven from hydrogen and helium, stretch far enough to swallow entire solar systems, while stellar winds blast through them at speeds exceeding 2,000 miles per second, sculpting the gas into those eerie, leg-like tendrils. But here's the twist: this nebula isn't just birthing stars, it's also tearing them apart. The tarantula's core is so chaotic, it's a graveyard for failed stars that couldn't withstand the radiation pressure. Some collapse into black holes before they even finish forming, while others get shredded by their siblings' gravitational tug-of-war. It's a stellar gladiator arena where only the strongest survive, and the losers get recycled into the next generation. This cosmic tarantula is more than a pretty Hubble image, it's a time machine. The light reaching us today left when early humans were just mastering fire, offering a snapshot of how galaxies built their stars in the ancient universe. And one day, long after our sun burns out, the tarantula's surviving stars will explode, scattering the elements for new worlds, and perhaps new life into the void. So while it might look like a spider, it's really a cosmic midwife spinning the threads of creation itself. Earth doesn't just have one moon, it's got a secret cosmic dance partner, and it's been hiding in plain sight for centuries. Meet Camolwa, a tiny asteroid no bigger than a Ferris wheel, locked in a bizarre orbital waltz with our planet. Unlike the moon's neat, circular orbit, Camolwa traces a wild, corkscrew path around the sun, staying close enough to Earth to appear like a distant, flickering companion. Some astronomers call it a quasi-moon, while others argue it's more like a temporary tag-along, a cosmic hitchhiker that'll eventually drift away. But one thing's certain, this little rock is rewriting what we thought we knew about Earth's celestial entourage. What makes Camolwa so strange? For starters, it doesn't orbit Earth directly. Instead, it's trapped in a gravitational resonance, looping around the sun in sync with our planet, always staying just close enough to feel Earth's gentle tug. Picture two runners on a track, pacing each other but never quite touching, sometimes darting ahead, sometimes lagging behind, but always locked in rhythm. This odd arrangement means Camolwa never strays farther than about 9 million miles from us, close enough to feel like family, but far enough to keep astronomers debating its true status. Then there's the mystery of its origin. Camolwa's spectrum, the unique fingerprint of light it reflects, suggests it might be a piece of the moon itself, blasted into space by an ancient impact. Imagine a violent collision on the lunar surface billions of years ago, sending debris hurtling into space, with one fragment eventually finding its way into this peculiar orbit. If true, it means Earth's second moon might literally be a long-lost shard of the first. But here's where things get even weirder. Camolwa won't stick around forever. Computer simulations suggest its current orbit is unstable, a fleeting celestial flirtation that'll last perhaps another 300 years before the sun's gravity reclaims it. That makes it less of a permanent moon and more of a cosmic houseguest, overstaying its welcome by geological standards but vanishing in the blink of an eye on an astronomical timescale. So does it count as a moon? That depends on who you ask. Traditionalists argue a true moon must orbit its planet directly, not just trail along in a shared solar orbit. Others say Camol's gravitational bond and persistent proximity earn it at least honorary moon status. Either way, its existence hints at a hidden population of near-Earth objects dancing at the edges of our gravitational influence, transient companions we're only now beginning to notice. And that's the real lesson here. The universe loves surprises. Even in our own cosmic backyard, there are still mysteries waiting to be uncovered. Like a second moon we never knew we had, quietly looping through the void, reminding us that even the familiar can hold secrets. So the next time you gaze up at the night sky, remember, somewhere out there, Camol is tracing its crooked path, a silent witness to the dynamic, ever-changing dance of the cosmos. On Mars, every sunset is a paradox. A world bathed in rusty red light somehow paints its horizon in cool, ethereal blue. This isn't just a different color palette, it's a masterclass in how atmospheres sculpt light under alien skies. While Earth's sunsets drench the clouds in fiery oranges and pinks thanks to eerily scattering where short blue wavelengths get dispersed by air molecules, leaving longer red tones to dominate, Mars flips the script entirely. Its whisper-thin atmosphere, just 1% as dense as ours, scatters light in reverse, thanks to fine iron-rich dust particles suspended like perpetual haze. These dust motes are about the size of cigarette smoke particles, perfectly tuned to bend blue light forward while letting reds pass straight through, creating that haunting sapphire glow around the setting sun. But the real magic happens because Mars's dust doesn't just hang in the air, it moves. Global dust storms regularly engulf the planet, lofting fresh particles high into the atmosphere. When NASA rovers captured the first high-resolution images of blue sunsets, scientists noticed the hue intensified after these storms, as if the planet was actively stirring more blue scattering dust into its skies. It's a dynamic canvas, changing with the seasons and weather in ways Earth's static eerily scattering never could. Here's the twist: that blue isn't uniform. While the halo hugging the sun radiates cerulean, the rest of the Martian sky shifts to a muted pinkish brown, a result of that same dust diffusing residual red light sideways. It's as if the planet can't decide whether to lean into its rusty identity or its icy alter ego. So it does both at once. Even the sun itself appears oddly diminished, a tiny white-blue disk just 2/3 the size we're used to, dangling like a lost pearl in that surreal twilight. This otherworldly spectacle isn't just pretty, it's a key to unlocking Mars's atmospheric secrets. By studying how light bends and scatters, scientists can gauge dust composition, density, even seasonal wind patterns. When the Perseverance rover's cameras caught a blue sunset in 2021, researchers pored over the data like art critics analyzing a newly discovered Monet, except instead of brushstrokes, they were decoding atmospheric chemistry. Yet the most humbling realization, Mars's blue sunsets are a reminder that nature has no default settings. On Venus, sulfur clouds turn sunsets into a dim, yellowish blur. On Titan, methane skies might cast an eerie orange glow. Each world's sunset is a fingerprint shaped by the unique cocktail of its air, dust, and light. So while we romanticize Earth's golden twilights, Mars whispers a cosmic truth. Beauty isn't universal, it's atmospheric. And somewhere out there, a planet with purple sunsets or emerald dusks might be waiting, ready to rewrite our expectations all over again. For decades, astronomers were haunted by a cosmic accounting error. Nearly half the universe's ordinary matter had gone missing. Not dark matter, not exotic particles, but the protons and neutrons that make up everything from stars to smartphones. This baryonic matter had simply vanished from the cosmic ledger, leaving scientists scratching their heads. Then, in 2020, the answer finally came into focus. The missing matter wasn't gone. It was hiding in plain sight, woven into a vast, invisible web of gas so diffuse, it had eluded detection until now. The culprit, something called the warm-hot intergalactic medium, or WIM, a ghostly network of superheated filaments stretching between galaxies like cosmic spider silk. These threads, invisible to traditional telescopes, contain gases scorched to millions of degrees but spread so thin, a cubic meter might hold just a single atom. Finding WIM was like trying to spot fog in a pitch-black room using only a flashlight. The breakthrough came when researchers realized these filaments subtly distort the light of distant quasars, acting like frosted glass across the universe's brightest lamps. By analyzing these distortions across hundreds of quasar sightings, the eerily X-ray telescope finally mapped WIM's elusive structure, uncovering the universe's hidden scaffolding. Here's what makes this discovery mind-bending. WIM isn't just scattered debris, it's the universe's filing system, storing nearly half the ordinary matter created in the Big Bang. When galaxies formed, they didn't hoard all their ingredients. Instead, they left trails of star stuff in the spaces between, like flour dusting a baker's counter. Over billions of years, gravity funneled these gases into filaments, creating a reservoir of matter that could one day birth new galaxies or feed existing ones. But the real kicker, WIM existence, hints at an even deeper mystery. While we've now accounted for the missing baryons, over 90% of the universe's mass remains dark matter, a reminder that for every cosmic puzzle we solve, another lurks in the shadows. WIM is both an answer and a question, a reminder that the universe doesn't just hide its secrets in black holes or distant galaxies. Sometimes they're hanging in the empty spaces we thought we knew. So next time you gaze at the night sky, remember, the void isn't empty. It's threaded with invisible rivers of matter, a hidden architecture holding the universe together, one faint glowing filament at a time. What if everything you see, the stars, planets, even your own hands, is just a projection, like a cosmic movie playing on the surface of reality itself? This isn't sci-fi, it's the holographic principle, a mind-bending theory suggesting our three-dimensional universe might be encoded on a two-dimensional surface, like a hologram etched onto the fabric of space-time. Imagine the universe as a glowing sticker where every event, every particle is just information painted onto its edges. The three-dimensional world we experience would then be an illusion, a shadow cast by deeper, flatter truths. The roots of this idea trace back to black holes. When matter falls into one, it vanishes from our universe, but according to quantum mechanics, information can't be destroyed. So where does it go? In the 1990s, physicist Leonard Susskind proposed that all the data about what fell in gets smeared across the black hole's event horizon like ink on a balloon. Expand this idea to the entire cosmos, and you get the holographic principle. Everything inside the universe could just be a translation of data stored on its outermost boundary. Now Fermilab is putting this theory to the test with an experiment called the holometer. Picture two laser beams split apart, sent down perpendicular paths, then recombined. If space-time is pixelated at the tiniest scales, a prediction of holographic theory, those lasers should pick up microscopic jitters, like a film projector stuttering on a frayed reel. Early results haven't confirmed the effect yet, but the mere possibility shakes our understanding of reality. If the universe is a hologram, then every galaxy, every thought, even the concept of here and now, might just be symbols in a cosmic code we're barely beginning to decipher. Here's the twist: this isn't just about physics, it's about perception. A holographic universe would mean that solidity, distance, and even time are emergent properties, not fundamentals. The screen you're staring at, just a cluster of data points rendered by the universe's hidden algorithm. Your morning coffee, a temporary pattern in the projection. It's like realizing the world is a VR headset running on laws we're only now glimpsing. Yet the most humbling part isn't the theory itself, it's the rebellion against intuition. Evolution wired us to trust our senses, to believe in things and places. But if holography holds, those instincts are cosmic mirages. The universe isn't just stranger than we imagine, it's stranger than we can imagine, operating on rules that turn our everyday experience into a beautifully rendered illusion. And somewhere, perhaps, the real universe is waiting, written in 2 dimensions, unfolding into 3, like a story we're only beginning to read. From neutron stars spinning faster than kitchen blenders to planets made of solid diamond bigger than Earth itself, the universe never fails to shock us with its unimaginable extremes. Who would have guessed that tears float in space as shimmering bubbles, or that black holes hum deep cosmic songs? Every discovery we've explored today proves one thing: reality consistently outdoes our wildest imaginations. Think about the sheer absurdity of 55 Cancri, a scorching diamond world where gemstone mountains tower over lakes of molten rock. Or consider neutron stars, where a teaspoon of material outweighs every car on our planet combined. These aren't science fiction plots, they're verified cosmic phenomena that make even seasoned astronomers pause in wonder. And let's not forget Saturn's geometric storm, Mars's upside-down blue sunsets, or the fact that our moon is quietly abandoning Earth. These are the moments that redefine what we consider normal in the cosmos. So which fact blew your mind the most? Was it the astronaut who grew 2 inches in space, or the nebula hiding 24 trillion Earth oceans worth of water? Drop your favorite in the comments. I want to hear which cosmic oddity stuck with you long after this video ends. Because that's the joy of space exploration. Every discovery leads to deeper questions, stranger mysteries, and the thrilling realization that we've barely scratched the surface of what's out there. As Carl Sagan once said, and it bears repeating every time we peer into the cosmos, somewhere, something incredible is waiting to be known. Whether it's a new type of planet, an undiscovered law of physics, or even signs of life beyond Earth, the universe still holds wonders beyond our current comprehension. So keep looking up, stay curious, and remember, the wildest cosmic truths are often the ones we haven't uncovered yet. The next great space mystery might be revealed tomorrow, and it'll probably be stranger than anything we've talked about today.